adapted from the article The Mars Model by Bridget Mintz-Testa, which appeared in Discover magazine. The first close-up images of Mars, captured in 1972 by the probe Mariner 9, were a planetary scientist's dream. They revealed networks of valleys that looked uncannily like drainage basins and steam beds back here on Earth, and thus implied that there had once been water freely flowing over the surface of Mars. The images also implied that Mars had once had a thick atmosphere. Our planet is blessed with liquid water on its surface only because it has a thick atmosphere to maintain a high pressure and trap the sun's heat. So planetary scientists proposed that when Mars formed 4.6 billion years ago, it too had a dowry of a heat-trapping atmosphere composed of carbon dioxide and water vapor, with warmth, water, and air. They speculated Mars once had been a garden world, a paradise among planets. So this first paragraph, the author introduces the first images that scientists were able to get of the surface of Mars. Those images revealed valleys that appeared to be water beds, or what once would have been water beds, which caused scientists to theorize that Mars may once have been very similar to Earth, had plant life, had breathable air, and a strong atmosphere. And most importantly here, the conclusion was that at one point Mars had an atmosphere very similar to Earth's that was able to keep the surface livable. But, as they also discovered, the garden didn't last long. None of the stream beds were younger than 3.7 billion years. Something happened to Mars, something that stripped nearly all of its atmosphere, killed its streams, and froze the garden forever. So this little transition paragraph here is setting up the main point of this article. So scientists hypothesized that Mars once was a garden-like planet, that it once had an atmosphere, but something must have happened to destroy that long ago. And now the article is going to examine what potentially could have happened. Researchers have suggested many scenarios for the Martian apocalypse. Some have proposed that the sun gradually whittled away Mars' atmosphere with its wind of charged particles. Others have hypothesized that the planet itself absorbed most of its atmosphere, turning carbon dioxide into carbonate rocks. For the past 7 years, however, Anne Vickery and Jane Milosh, two planetary scientists from the University of Arizona, have been exploring a far more spectacular ending. Most of Mars' atmosphere, they suggest, was blasted away by a succession of asteroids and comets. So this paragraph introduces a couple theories for what happened to Mars' atmosphere, but the last one is the one we're going to focus on in the article, and that's the theory that asteroids and comets striking the planet actually blew the atmosphere away. So let's read on about that theory. The basic idea, Milosh says, is that an impact doesn't just open a crater. With high velocities, the projectile vaporizes and expands into the atmosphere. This superheated expanding plume shoves the atmosphere above it like a snowplow, pushing snow to the heavens. How high a vapor plume goes depends on the mass and velocity of the object that crashed into the planet. If it is big enough and fast enough, it can drive its plume straight back up into space. The portion of the atmosphere it plows away is then stripped from the planet forever. So these researchers say that as long as large, fast asteroids have been striking Mars's atmosphere for hundreds of millions of years, billions of years, that could be enough to destroy the atmosphere of the planet. To see if this process could account for Mars's missing atmosphere, Vickery and Meloche essentially ran a film of the red planet in reverse, starting with today's wispy atmosphere and adding back the air that might have been removed by impacts over the eons. First, they derived a mathematical expression relating time to the rates of both impacts and atmospheric loss. Using this expression, they then ran the clock backward to find out how long it would take to grow an ancient Earth-like atmosphere from Mars's current tiny one. If their model was right, it would produce the original, early Mars. And the time it took to grow a thick atmosphere by going backward would be the same as the time it took to lose a thick atmosphere traveling forward. Using an impact rate that prevailed 3.7 billion years ago, one impact every 10,000 years, Vickery and Meloche were able to start with a virtually dead planet and grow a thick atmosphere in only 600 or 700 million years. So this paragraph describes the researchers' methods. We can't go back in time and see what happened to Mars in real time, but what we can do is create mathematical models that simulate what might have happened to the planet. And that's what these researchers did. They made a mathematical model, and then they looked at how long it would take moving backwards to get Mars to look like the garden world that had been theorized. And they found actually that it was quite possible, using their hypothesis, to get there in only 600 to 700 million years. However, now that an attractive explanation finally exists for how the young paradise of Mars was destroyed, some researchers are questioning whether that paradise ever existed in the first place. Studies of other stars suggest that the young sun was 25 to 30% dimmer than it is today. Mars, which is 49 million miles farther from the sun than is Earth, would have been receiving less than a third of the sunlight we now enjoy. Some scientists have calculated that given so little sunlight, Mars's atmosphere wouldn't be able to trap enough heat to keep water from freezing, and that under such conditions, carbon dioxide would form frozen clouds. What little sunlight Mars received would bounce off the clouds, and the planet would cool even further. As to how the Martian valleys we see today might have formed without a warm atmosphere, it is suggested that the planet might have been covered by large expanses of ice, and that the heat from Mars's interior could have thawed out hidden channels. So here's some evidence counter to the previous theory. Some scientists are saying maybe Mars was never really a garden planet. Maybe the sun, there's many millions of years ago, was too dim to allow the planet to be warm enough to create that kind of atmosphere. So instead, they proposed some alternate theories for why Mars's surface might have formed the way it did that don't necessarily have anything to do with liquid water, with breathable air, and all of those concepts. Vickery, however, is sticking by her original assumptions. There exist on Mars valley networks that look like terrestrial river valley networks and don't look like any other kind of feature found anywhere else in the solar system, she points out. The first, obvious interpretation is that these networks were formed more or less the same way as similar terrestrial networks. So here in this concluding paragraph, the researchers who we were discussing earlier with their asteroid impact theory are still sticking to their original assumptions. So they're disregarding that evidence in the previous paragraph to say that, according to their research, It still seems like Mars did at one point have liquid water, have a livable atmosphere, and therefore they still believe their research is consistent. So we have some controversies in the modern interpretations of why Mars looks the way it does and what the planet may have been like millions of years ago. Some evidence supporting both sides, but the particular researchers we're focusing on here are confident that their research is very meaningful.